And another one where it's just not really interesting to see me rage quit working with Python. Work live with the robot itself. Would be sick, wouldn't it? How about you? It would be sick to make. And this little example that we see right there, was it easy to make? No. Did I almost consider throwing the project out of the window while developing this one? Yes. Can be f***ed up by just forgetting one single space. That plays on my patience a tiny little bit. Hello everyone, welcome to part 11 of me working on a 3D printed 2D pen plotter robot. The last couple of weeks have been hectic between work and freelance projects, but I still have some new things to show you, and maybe we can try to make it interesting. So essentially this is what I've been working on, the visual representation of the robot. I have been trying to make 2 videos in a row of me actually coding live, but it was not very frugal. One time forgetting to record the sound, and another one where it's just not really interesting to see me rage quit working with Python. Because I love Python. Everybody loves Python. But anyways, the goal of this that you see on the screen is to have a visual representation of what we talked about in previous videos. Essentially, the inverse kinematic model of the robot. Give it an X and Y position, here represented by this little red dot, and where the joints would locate themselves according to their target position. We don't really need this to make the robot work, but I think it was necessary to first of all test out the mathematics, and also it can just be fun to have a visual representation of what is actually happening in the real world. Like, imagine if we could actually make this work live with the robot itself. Would be sick, wouldn't it? Would be sick to me. How about you? Would be sick to me. And this little example that we see right there, was it easy to make? No. Did I almost consider throwing the project out of the window while developing this one? Yes. But we made it through. Obviously, this is not perfect. There is still so many things that I would like to make better, essentially. For example, as you can see, this is on the top left corner. I would like it to be a little bit more central. The code is nowhere near being perfect. Like in some places, just using functional things, and then all of a sudden we have a big class, this millimeters to pixels thing, even though we use centimeters for this representation. It's just an overall mess. The thing I'm very happy about though is that I somehow succeeded in making this parametric, if I can say so. For example, like in previous videos, we talked about the fact that the end effector, so essentially where the pen would be, is not at the exact intersection of the two joints, right? It's a little bit off-centered right there. So by a little bit of a lever that we call, so like this is the supposed to be end effector, this is the end effector, and like we call this a lever. This can be prone to change in the future, wouldn't it? And so for that, I just made those constant variables right there with the joint length and the lever length. So let's say like this was a 5, I can make it bigger if I want to. So let's say this becomes 8, and as you will see, the lever is now bigger. And same thing with the lever beta, aka at what angle is this lever from this joint. Right now it's a perfect 90 degrees, aka pi divided by 2. But what if I'd make this angle smaller, let's say divided by 4? It crashes. Cool. Yeah, it crashes because I don't have the securities pointed. But yeah, you see my point. Right there you can see that like this angle is smaller. So I made this in Python, and was Python even a good idea? I think so for multiple reasons. First of all, the big why. Why Python? I think this project is very multidisciplinary between electrical engineering, mechanical engineering, 3D printing, and all that kind of stuff. But when it comes to just software, we also have the firmware of the robot made in Arduino, which is kind of C++. Someone's for sure is gonna shit on me on the comments for this one. And for the communication between my actual PC and the robot, I could have went multiple different directions. JavaScript could have been one, processing maybe, if I could have access to the COM ports, but Python seemed to be the way to go. I did touch Python when I was in college, but nothing too extensive, where I always felt that I missed a little bit of a thing on that department. It also seemed easy to put in place and integrate in its own Git repository, so that was also another thing. And also cross-platform, right? I could have went as deep as making this in C, using multiple different graphics API according to when I am on a PC or a Mac or Linux or that kind of good stuff. But this is just working out of the box, and I can work either on my home PC, which is right there, or on my Mac, which is pretty nice. I just hate the indentation though. The fact that your functions, your if statements or whatever can be f***ed up by just forgetting one single space, that plays on my patience a tiny little bit. But in any ways, this is somehow going well. Somehow, I'm learning a bunch. You guys seem to enjoy it as well. And it's just a good ongoing adventure. I am not as fast as the first time I worked on this project for multiple reasons. First one being excitement. As you know, if you are a tech guy and you have multiple side projects, it's very difficult to push through the moments where you are blocked on something, when you are blocked on something, goddamn. And also I'm working on many different freelance projects on the side right now that I hope I will be able to talk to you about very soon. So you should follow for that. God damn. In any ways, these are the news. I hope you enjoyed it. I hope you had a wonderful week. Like, subscribe, give me tips in the comments down below that I always read. Always. And I see you guys soon on the internet. Bye bye everyone.